Business, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and sitting in this week for Gary Kildall is Herb Lechner of SRI. Herb, what we have up on our Apple computer here today is the Koala Micro Illustrator and my handy Koala pad here. And we see a menu of some artists' choices, and if I can, I'm going to try to communicate to you here in some computer graphics. And so far, it's working. If I get your name right. There we go, and I can even make it a little more sexy than that. We'll give you a little brighter background color so it's a kind of more upbeat message. Herb, computer graphics is the subject of our show today, and computer graphics, in fact, involves more than just this little thing we're playing with or even video games, which some people associate with computer graphics. There are some pretty serious applications, aren't there?
Very much so, Stuart. Computer fine art hangs in galleries right alongside of traditional art. And of course, in the commercial area, computers aid animators and play a very important role in TV advertising today. And of course, the basic building blocks of computer art, that is the graphics subsystems, play a role not only in art, but in related activities such as computer-aided design and other graphic applications.
Okay, on today's program, we'll be looking at one of the newest computer graphic systems called Iris. We'll look at a computer art system called the Paint Box, and we'll meet two computer artists, real people, that is. First, let's take a look at the kind of computer art being done now on mainframe computers. Since the first light pen and graphics displays of the 1950s, computer-assisted artwork has been associated with beautiful, if mathematical, images of symmetry and abstraction. But the applications today extend far beyond repetitive patterns. With enough computing power, computer graphics can extend an artist's reach to cover the height and length of a wall, or compress the time it takes to animate something from a month to an hour. Using a digitizing tablet, MIT artist Ron McNeil chooses from a palette of colors and pre-programmed images to create a collage that exists only in the computer's memory. Before ever seeing a canvas, it undergoes some dramatic transformations. Starting with materials from different sources like photographs or three-dimensional objects, the composite can be manipulated to change in color, size, or geometric aspect. The screen-sized image shown here is only an intermediate step toward the final hard copy, a painting that is 14 feet high and 48 feet long. Like a colossal paintbrush with a memory, the giant XY plotter magnifies the completed artwork into a wall-sized mural, strip by strip and color by color. As an ingenious collaboration between digital imagery and robotics, the giant plotter is unique. But the special talents of computer graphics are increasingly used in another area of the visual arts, animation. To an art form that was once the near exclusive province of film, computers offer a much faster method of animating images. Again, through a digitizing tablet, an artist can create a figure by drawing in just enough points to determine its size and rough shape. For a symmetrical object, all the computer needs is the outline of one side, which is then shaped into a fluid form, regenerated, and filled in with color and three-dimensional detail. The software calculates and reproduces the characteristics of light and shadow that the object would possess in 3D. Finally, to animate the drawing, the artist specifies some key camera positions from which the object is viewed in space. The program then fills in the missing frames that simulate movement between those points. Making a drawing come to life is the most tedious part of an animator's job. Fortunately, it is also readily adaptable to digital processing. The systems used to produce these images are not designed to replace artists, but to assist them. And with enough human talent, they can mimic reality in detail or expand it to the fringes of our imagination. Our guests around the table now are Michael Arendt. Michael's a computer artist and design director with Aaron Marcus & Associates in Berkeley. And next to Michael is Don McKinney, vice president with Silicon Graphics here in Mountain View in the Silicon Valley. Herb?
Michael, in your consultant role, you use all kinds of computers graphics equipment. You have a setup here today for us. Do you want to tell us a little bit about this equipment and what you're going to do?
Well, this is an 8-bit microcomputer, which is very similar to the type of computers that most of the viewers would use in their home, for instance, to play games. And we use these type of systems, for instance, to create imagery for digital directories and education software and such like that.
And what exactly do you show us how you use this system here?
Okay, well, the traditional artist tool is a brush. This is an electronic artist tool, and it's using a graphics tablet, which you see here, and an electronic pen. And with this, I can paint images and put graphics, combine graphics, photographic images, and text on the screen. I can very quickly load in an image here, for instance, to show you a raw photographic image that was input using a video digitizer, which is simply a video camera. And once I get the image into the computer...
That's an unfortunate example, by the way, Michael, but we'll go with it.
Once I get the image into the computer, then I can use this graphics tablet to take away parts of the image that I don't want. As you can see here, it's loading in this microcomputer.
What do you mean by parts of the images you don't want, Michael?
Well, for instance, maybe I want to take out a background and put in another background, or I want to take out areas where I would like to put in other types of things like text and things like that, which I'll demonstrate here. I'll show you, for instance, I'm showing you the build of an image.
Don, while Michael is working here a second, there are great memory demands, aren't there, in doing graphics? How do you accomplish that with just a small microcomputer?
Well, and really it depends on the exact amount of memory. The memory requirements really are the requirements of the amount of color that you have, and also what we call the resolution of the screen. So the higher and smoother the image appears, the more memory is required. In the case of what you'll see later today, we have approximately 3 million bytes of memory just used to store an image in real time.
Okay, Michael, I'm sorry, you're ready.
Okay, now I've taken away the background. Now I've put in a cartoon bubble here. And then I can load in another image here to show you other things that I've...
So you're loading images you've pre-prepared?
Yes, I pre-prepared these images.
How did you go about getting the old background out? Did you trace around it or something?
Yes, you can block it out with a function on the tablet using a black background blockout. And then so, as you can see, the image is slowly building here, and then I'll show you the final image that I've created. And then I can show you how you can manipulate that image other ways also.
What is the tablet you're using? Tell me how that works.
Well, it works by addressing various areas in the computer memory, and essentially it's giving it a command either to put color onto the screen or putting geometric figures on the screen like circles or grids. And you can also put text on the screen, as you see here. Here's the final image I've built, which has a combination of a photographic image. It has graphics in the background, and it has text also combined with those graphics. And I've been able to do that with this tablet. I can also, for instance, do things like turn the image upside down, or I can also flip-flop the image this way here, and then I could bring it back up. I can also invert the colors, for instance, so I can make it negative or make them in new colors. And then there are other functions on the tablet, too, that you can do. For instance, you can create textures with what's called electronic brushes and things like that.
Okay, well, we're moving our way up from the simple koala pad to something more sophisticated, and Don, that gets us into your area. And I think you have your Iris system set up over in the other part of the studio here, so let's take a walk over and see what Iris does. Don, how does your Iris system here differ from what we've seen up until now?
Up until now, we've really been looking at microcomputers, really personal computers, and this is really a different class of machine. The biggest difference, though, that separates us out is the idea of us using custom chips developed by Silicon Graphics for our own use to do these three-dimensional calculations. This example here is the Rubik's Cube, and what's going on here is we're calculating the location of all the endpoints of all the faces so that we can rotate those in 3D and do all the hidden surface removals all in a very real-time mode. Why don't we go on to the next demonstration here to give an idea of how our machine can be used.
What kind of machine, what's the hardware we're using here, Don?
This is a terminal configuration that has a little floppy disk on top, but the basic computer that we're using here is a Motorola 68000, often used in some of the other reasonably high-performance microcomputers. The other chips that we actually have are called what we call our geometry engine, and it's a high-speed three-dimensional floating point calculation unit that runs at 6.5 million floating point operations per second. This speed we are planning to enhance to over 10 million floating point operations just in a few minutes.
What's the demo here?
This one is a series of pictures of a series of buildings where we're doing a calculation in real time. So I'm going to angle up away from the buildings, and I'm going to zoom back away. And as I'm zooming away, you can see this building going further and further back. You can see that the light sourcing is done so that the certain surfaces that are closer to the rays of sun are visible. Now what I'll do is I'll add buildings in 3D. So you can see as I move around the space, I can actually get the full panoramic effect of this block, or I can even zoom in. So I can go through areas. Let's skip on to the next. The next is...
before we get to that, Don, what would the application be, say, of something like this architectural thing you just showed me?
We have several customers that are in the AE&C market, the architectural engineering and construction business, and we have several local companies that are doing piping diagrams and piping calculations for intersections of pipes in, say, nuclear plants. Another case might be for an architectural firm that would add software to our product and sell it to the end-user architectural people for doing building design, for doing construction of faces, landscape architectural design, even an interior decorating. Use it to place desks and furniture within a given room.
Okay, tell me about this demo now.
Okay, this one is, again, it's a three-dimensional object. It's a rendering of a robot. So the first thing I'm going to do here is get it a little bit larger. And then what I'll do is I'll tip it over so you can actually look at this robot arm from the top. And I'll spin the arm around. And now as I'm closer, let me tilt it back up so you can see it from the front view. And in this case, what I'm doing is I have one button. By touching it, I can cause the shoulder to move the entire arm up and down, or I can cause another button can cause the forearm to move up and down, and then the last series I can cause the pinchers to actually open and close, or to even grip something. An application for this might be an auto assembly plant where you're grabbing a metal part to be welded into another area.
Okay, we have time maybe for one more, and I'll load your disk for you.
Okay, this is another sophisticated 3D application where we're actually computing the location of an aircraft in flight. So the first thing that will happen is we'll be looking out the front of the airplane at a building or a hangar, and then we're going to taxi up the runway, make a right turn, taxi down the runway, make another right turn, and take off.
Okay, and you talked about the speed of about 6.5 million. What was the units?
Floating point computations per second. Most computers are measured in MIPS, and some are measured in what's called flops. And the difference being that it's either an integer mathematics or it's a floating point mathematics.
Okay, let's see what this is.
Okay, so what I'm doing now is I'm sitting at the runway. I'm going to accelerate the plane as it goes toward the building. I'm turning the rudder now using the mouse and locking in on a direction. And then I'm going to sweep around and get back onto the main runway. And now as I'll accelerate the plane still further, raise the flaps, just like in a normal takeoff, I can switch between the viewing angle of the pilot looking out the front of the window to the viewing angle of the from the tower, and now I'm off the ground.
Don, that's very impressive. Okay, if you watch television, you are familiar with computer graphics. Some of the effects you see on the Computer Chronicles are in fact generated by computer. Well, we'll see a very sophisticated video computer graphics system in just a minute. Joining us now is Ann Chase, who is a freelance computer artist, and Kevin Prince. Kevin is engineering manager at MCI Quantel. Now, Ann, you played around with a picture of me at the break just before we got to the segment. That was animation, I take it, and how do you do that with this system?
Well, basically, I can find that animation stack in the library and show you how I set it up. Just by tapping. It's cell by cell is how it's set up. And here you can see that I just drew the tie and rolled it up on your neck.
So you captured the real picture and then drew on top of the real picture and then just did the cell animation.
Right, just cycled the animation in.
Does this machine do all that with just commands that you give it?
Yeah, basically just your artistic ability and what you can do using the capabilities of the machine.
Kevin, what are the capabilities of the machine? What kind of hardware, software is supporting this system?
Well, hardware-wise, we're based around the 68,000 processor, as previous people were talking about. But we've got a lot of dedicated hardware to do all the fast wipes, the actual painting and drawing in the system, and changing all the brush sizes, etc. It's taken us some time to develop that, but associated with that is, probably more importantly, is the actual software interaction with the user. Everything you see is obviously a very large operating system that we've had to divide for the system.
Anne, could you show us, you mentioned drawing and brush strokes, some of the freehand capability of the system?
Basically what I'll do here is just wipe the canvas, and you can see that I'm in a paint mode. And this shows me my brush size, and I'll take a white here, and you can see that I can just paint right on the screen. I can choose a different color just by tapping and say a larger brush size and paint over the top of that. Then I can go back and choose that mixed color right off the image and store it to use later.
Now, this is obviously much finer drawing, greater resolution than some of the earlier things we saw at the beginning of the program. That's a function of what, Kevin?
That's basically the way we do our store manipulation, the way we actually store the picture. We have various methods of mapping the image that we're actually trying to work with into the store. Very different to individual pixel operations, which the other machines will be working with.
And Paintbox is in fact in use right now in television graphics. How is it being used?
Well, most of the networks have actually got several of these systems, and they very often use the machine for their news production. And practically every night you will see some form of over-the-shoulder shot that's probably been generated on the Paintbox. But hopefully it's so good you would never notice.
Now, this system gives you the capability of mixing that which is artistically drawn with that which is real-life photograph sort of a thing. How is that done?
Well, actually, I can just go to the live source, and you can see that right now we're taking in a live video source of what we're doing, and at any time I don't even look at myself. Let's just tap something down and see what we have here. There we have me. And I can go ahead and manipulate this right now.
So you have just captured a still frame from this live coverage of what you're doing right now, and now you can paint with it.
Right, or I could, let's say I'd like to create a stencil. And just very quickly, I can go in here with a stencil medium and just outline something and fill it.
And why are you filling that now?
What I'm going to do is a cut and paste technique. This is a stencil medium that's laid over the image. What I'll do is...
This is the word processing of art. Cut and paste.
But that's it, yes. And then I'll just paste it up.
At this point we're taking a portion of that image, and we've now got, as you can see, two images.
There we are.
Twins.
I think that's a vast improvement.
That's right. That's rather incredible. And you seem to have a lot of fun doing this. Is there is there resistance to an artist, or shall we say a pure artist who's used to dealing in brushes and paints, getting comfortable with using this technology?
Maybe at first it's a little difficult to use the menu, to learn to think and actually read at the same time while you're drawing. But once you've worked with the system for a short period of time, it's just like second nature. Very simple to use, set up in artist terms.
It's clear how valuable this would be to a television media. What about the area of fine art? And is computer art catching on there too, or growing?
Definitely, definitely. It's the wave of the future. That's what's going to be happening in art in a couple of years. In fact, it already is.
Should brush manufacturers worry?
No,
I mean,
no.
They're not in trouble yet.
Not yet.
Kevin, we have about a minute left. How far can you go with this technology? Will we get to the point where you could have, where we could be replaced by animated people and sync it up with words?
I sincerely hope not. The way I see it at the moment is that we're providing the means by which an artist can extend their capabilities. We can turn a reasonable artist into a good one and an extremely good one into a superb artist. All we're doing is allowing them to create their artwork in a much shorter space of time and in the medium in which it's required.
Well, that's fascinating. And you don't exist anymore on that picture, Kevin, but we know you're here. We're all out of time. Thanks so much for being with us. Thank you for joining us on this edition of the Computer Chronicles.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.